everybody, to the Data and AI Specialist track at PyCon AU. Did everyone enjoy lunch? Did everyone enjoy lunch? Thank you. Alrighty. Now keep that energy nice and high to welcome to the stage our next speaker, Stephen Tierney, to present Taking Back the Streets, NaviLens and the Fight for Open Navigation. Big round of applause. Thank you, everyone.
Thanks, everyone. It's great to be back at PyCon, and being back in Melbourne is really relevant to this talk. So I want to start by saying that I'm not actually affiliated with NaviLens, and this is a critique of NaviLens. The University of Sydney is funding me to be here, but these are my opinions, not my employers. So the goal of my talk is to highlight the problems of the NaviLens system so that we can think about future alternatives. This is mostly a talk about access and ownership of data. And this is a project that I've been tinkering with since 2024 and was accelerated by last year's PyCon, where I crowdsourced a dataset from the PyCon attendees. So first I'm going to go over how NaviLens works, and then I'll move on to explaining the problems or the issues with NaviLens and future directions. So to start with, I need to give some context about NaviLens, and I need to go all the way back to QR codes. So you all probably use QR codes on an almost daily basis. You would have tried to connect to the Wi-Fi with the QR code, and it didn't work today. QR codes were invented in the early 90s by Denso, one of the largest OEMs for car parts. Denso developed QR codes as a way to track inventory and production lines in Japan, and they were originally designed to hold multiple barcodes worth of data which could be scanned at once. So instead of having to scan in a warehouse multiple barcodes, you can just do one scan. So Denso patented QR codes, but has chosen not to enforce them. Instead, they openly share the specification and allow anyone to freely use them. QR codes are great because of that free spec, and that they can encode a lot of data, and we can also use them for kind of any purpose that we like. We can put URLs or any sort of arbitrary data that we want in there. So that's all great, but QR codes kind of suck at two things, and that's navigation and accessibility. So you have to be close enough to the QR code so that your camera can visually resolve each of the cells in the tag. We'll just ignore the sort of CRC or the checksum that goes along with it. The QR codes is for this purpose. But the other problem is that you generally have to be standing still. If you try to scan a QR code on a moving object, it's quite hard. You also have to be pretty accurate with pointing your camera or your device at the QR code, and you have to know where that is in the environment. So if you have a visual or motor impairment, it's really hard to actually use QR codes. A person that suffers from both Parkinson's and glaucoma is really going to have a hard time using a QR code on a tram as it rolls by. To solve this problem, some researchers at the University of Alicante in Spain, sorry if I got the pronunciation wrong, developed a simpler tag. These ddTags, short for distant dense tags, consist of a grid of CMYK cells. The low density means that with these tags, they can be scanned at a much greater distance than QR codes because we can accurately resolve each of the cells. And it also means that they are much more easily scanned on moving objects, either yourself or the object is moving relative to you. You also don't need to be super accurate with pointing your camera to locate these in the environment because of that low density. You might have already noticed some of these tags in trams if you've used the tram system. They were trialled in 2023 and rolled out to the entire network in 2024. You can find them at tram stops, on tram exteriors and interiors. So on the left, you can see an example at a tram stop, and on the right, if you look towards the top left of the tram, you can find a NaviLens code there, or a ddTag. The tag design is pretty similar to other tag designs. There's not a lot of innovation here. There's cells dedicated for data, error correction, and orientation. The main change is that it uses color to make up for the lack of pixel density. Due to the color, each cell can represent up to 2 bits rather than a single bit, like in a QR code. And this means that a 5x5 tag holds 24 bits of data. And you might be wondering, how many unique 5x5 tags are there if you can only hold 24 bits of data? That's roughly about 17 million, which presents a problem that we'll talk about maybe later, or if there's questions or time at the end. And the other issue with ddTags is that they are patented until 2037. So now that we know about the tag system and kind of the motivation for why we'd be interested in using a different tag, we can move on to NaviLens, the system or the service. And this is a service that associates data to ddTags. Users can scan the environment while running the NaviLens app, and any detected tags are scanned, and the associated data is returned to the user. NaviLens can improve wayfinding accessibility for the visually impaired, and it can provide detailed information about the environment, which is presented to the user either in a textual or audio form. So you can see an example in the image here, which I've pinched from The Guardian, of someone with a visual impairment scanning a tag on the Route 86 tram in Melbourne. So NaviLens is quickly becoming a de facto standard for orientation, mobility, and wayfinding for the visually impaired. It's even being used directly on consumer packaging. So you can see some examples. It's on the bottom left of the Coke box and also on the Kellogg's box as well. According to NaviLens, the user base has doubled every year since 2020. Of course, those with visual impairments are also going to benefit from this by getting that additional data that's provided through the app. For example, if you're in a country where you don't speak the native language or the local language, you could use the tag to provide you with some information about a product or a service. So how does it work? We know now that a ddTag can't really hold a huge deal of information with only 24 bits. So NaviLens relies on a web service to provide the associated data for each tag. This means that every NaviLens scan goes to the NaviLens service to fetch the data. If you want to make a compatible tag, you have to register through the NaviLens service. So my little diagram shows taking a picture or scanning the environment with the NaviLens app that goes over the network to the NaviLens web server, hits the tag database, which I've got a simple example of, which really boils down to having IDs associated to each tag, an owner of that tag. In this case, I've picked Yarra Trams, and some data that will be returned to the user. The NaviLens system, in effect, creates a physical namespace, or at least that's what I'm calling it, where parts of the world are represented as integers in each tag and in NaviLens' database. NaviLens divides this namespace up into at least 3 segments that I know of. They don't really go into a great deal of detail about how this works. I'm inferring from using the app and publicly available information. The first block is for general purpose tags. These are things like general purpose signage for bathrooms, emergency exits, and those sorts of things. The second's reserved for personal use, so you can try before you buy with NaviLens and get up to 10 free tags. And the last is for commercial use, which are purchased as leases. So if you're a company like Yarra Trams, Coca-Cola, Kellogg's, you need to purchase a lease. And you may notice the similarities of this to IP address allocation or the domain name system. Now onto the problem. So NaviLens have created a de facto standard which is quickly spreading. And the European Accessibility Act, effective from 2025, has forced many organisations to adopt the NaviLens system because they have no other choice to meet their legal obligations under that act. The potential problem is that NaviLens has basically a monopoly on this physical namespace, and they're a for-profit entity. So that means they're in somewhat of a position of control. They can restrict access to the system or charge whatever they like to use it. So this means that taxpayers could be rorted through extortionate fees that governments are charged. We know what government contracts are like. Smaller organisations or non-profits or general communities may be locked out of this system. For the moment, NaviLens is playing nice, but there isn't much regulation in this space, and like I said, they're a for-profit entity. Which brings me to a compounding problem, which is that recently NaviLens received a huge investment from a venture capital firm. So that puts the pressure on NaviLens to eventually turn a profit at some point, which is somewhat scary when we're designing for accessibility. The last issue is privacy. So every tag that is detected is sent to the NaviLens servers if you're using their app. And according to their terms of use, this means that each request contains your location, the date and time of the tag recognition, identification number of your mobile device, your email address, and a few other small metadata pieces of information. So this fact, I don't think, is very obvious to people who are using the NaviLens app, because most people are used to the QR code experience, which doesn't reveal your information to such a degree. We'll ignore sort of link services for QR codes. So This data could be exploited for various purposes, maybe by law enforcement, governments, to track individuals, or your data could be sold on to a third party. Currently, the privacy policy of NaviLens doesn't have provisions for this, but of course they can change that at any time. And remember, if you're not the customer, you're the product. So the purpose of this talk is to try and bring these issues to everyone's attention, and then try to encourage organisation in the community to try and come up with a compelling alternative and ensure equitable access. So this might mean coming up with an alternate tag system, or it might mean adopting the in-use ddTag system. And what's this got to do with Python? So we're 18 slides in, and Jack's probably questioning why he even gave me this speaker slot, because I haven't mentioned Python once. So through Python, we have the tools to do this and build an open alternative, to the point where if you've used these libraries before, building a viable detector is kind of a weekend project. So I've written a prototype library for the creation and detection of ddTags. This library is about 500 lines of Python, and I've designed it so that it's an easy to understand reference implementation. It's not particularly performant or intended for real-time use. Commercial use is at your own risk, since NaviLens may try to enforce their patents. So how do we create a tag image with this library? I've tried to make it as simple as possible. We come up with a string of ones and zeros to represent the message or the integer that each tag or the tag that you want to create will encode. And then you pass this to the from message function, the method with the size of the ddTag. In this case, it's a 5x5 ddTag. And with Python, it's not too hard to start from an integer and generate an equivalent binary string. On the other side, we can load an image and use the ddTags function to actually search an image for one or more tags. So I've tried to make this as simple as possible for you to use. Just accepts a pillow image and the expected size of the ddTag, and it will return back a list of tag objects. Okay, and this is where I get to go onto the demo of this in action to prove to you that this is a live working thing. And we can enjoy the gloriousness of the DVD logo tracking demo that I've set up. So this is my ddTag detection code tracking a little simulation I've made of this tag, and maybe it'll hit the corner. We'll see. So this is functional, it works. There are some problems with this library, which I'll get to at the end. Okay, I'll go back into slideshow mode. Okay, so what about the web server? So that's one component of that, of the NaviLens system. But I've gone ahead and taken the liberty of mashing together Django and Green Unicorn or Gunicorn to solve this problem. Mostly I've chosen Django because it provides a nice, easy-to-use back-end web admin interface so that we can go in and make corrections to tags if we need to update the data associated with each tag. I've released this, made available as a Docker image, so if you're a Docker fan, you can just run this one-liner and get a NaviLens service started locally on your computer, or deploy it to the web if you want to do that. Just to show you that that also works, so this is the system. You could put in whatever you want to put in as your message, so we could do never gonna give you up, create tag. I've already created a tag. It's recognized that, and it's returned the tag image for me. I could download it in various formats and so on. All right, let's go back to presenter view. Sorry, give me a sec. To full screen. Okay, so what can we actually do about this right now? As individual contributors, it's pretty challenging to create a major social change or something, a large system change like this. So I think the best path forward is to create a compelling open alternative to the NaviLens system. And even if it doesn't overtake NaviLens as sort of the de facto system, it's probably enough leverage to keep them playing nice. So here's some things that I think could help with that right now. The first is the image data set. So in last year's PyCon, I started a Discord thread where I asked for people to submit images that they'd taken of Melbourne's trams or the various parts of the tram system with ddTags on them. And I used these images for testing the library as I was developing it. So for the data set, we need variety and realism. This means different lighting conditions from different devices, different perspectives, and so on. So don't worry if you've still got a 10-year-old iPhone or your camera has a weird defect. That is sort of a perfect candidate to add to the data set. I've started up this again this year, so if you're on the Discord, you can go to the travel channel, and there's a thread in here for the NaviLens dataset. So if you'd like to contribute, just post your image in here, and I'm assuming that you're okay with it being publicly shared for permanent inclusion in the dataset. Discord should strip out any EXIF data, so your location information and so on should be removed. Or you could also help the project with code contributions. So there are issues already on the GitHub that I haven't been able to solve. This one is an example where NaviLens is actually not adhering to their published verification or decoding process that I need help with figuring out. There's also issues that I've listed on here for potential improvements that we could add to this library. The library also needs better infrastructure, and also the repository needs better infrastructure. So if you're into test cases or writing GitHub workflows, then that would be appreciated too. Lastly, I'd just like to wrap up by saying thank you to my partner Jasmine for helping with me with the slide design and bearing with me as I take an enormous amount of photos of Melbourne's trams. Thank you.
Thank you.